multiplication, or in other words, it takes values that are the same and then compresses those down, similar to how you would think of like a zip file. So if I have page compression, that automatically includes row compression, and row compression is the least compression that you'll get, but then the best performance if you do have to make updates. Page compression is the more you'll have greater everything else. We've got some information in our system views, and let me just go ahead and run this, and I just want to show you the difference in size between the three tables. The first one, my big transaction history, is the one I started with. And you'll see that one of these has the same row counts, but my big transaction history is quite a bit larger than the other two. You'll see that there is a decreased number of pages. So what's happening here is whenever I said you can get an improvement in performance because SQL Server will not have to access as many pages whenever you do a select. So you'll notice that you can also tell here with this which type of compression is being used. And I'm going to set statistics IO on, and I just want to do a query that will compare the logical pages. Thin query in each one of these tables. And it should only take hopefully less than 10 seconds to run. And there we go, 10 seconds exactly. I'll take a look at the messages here, and you can see that the logical reads were very much decreased for the row and then even further for the page. So I like to use logical reads to help me gauge the difference in performance. So that SQL Server is going to have to do a lot less work, has better performance if I do a scan or if I do query against a compressed table. So I'm going to go back to the slides and go to the next one. Okay, the next feature is partitioning. Partitioning is really great, especially for data warehousing. So what this means is, let's say I have a lot of data that I need to load into a table. Now, normally what would happen is I would have locks, and let's say I was loading millions of rows into this table. Obviously I'd want to do that during an off time because I would be preventing users from running queries against that table. By using partitioning, I'm able to use a technique where I swap a partition from take a table and swap it into another table, and it just takes basically a split second. So obviously I'd be able to do something like that during busy times, and it wouldn't matter, it wouldn't cause a problem for my end users. Another reason I might want to use partitioning is that I may want to divide my data up and put older data that I no longer care about on a slower disk. So with partitioning, I'm able to take that table and divide it up onto different drives, different file groups. There are also some interesting query optimizations with partitioning. So basically, if I know, or I should say SQL Server knows that all of the rows needed for a particular query, the results of a particular query are on one partition, SQL Server will not access those other partitions. SQL Server will only query the partition that qualifies. There are some other optimizations. So earlier in the history of partitioning, like at the SQL 2005, there were some issues where parallelism was not applied to partition tables unless you were only accessing one partition. So that's been fixed. I believe probably around 2008 that's been fixed, and so you can get parallelism for each partition. So I'll go ahead and show you a demo of that as well.
Hey, Kathy.
Yes?
I hate to interrupt you, but your audio is breaking up slightly. I'm not sure there's any connectivity, troubleshooting things we could try really quickly, but it's slightly breaking up.
Okay. I'm not sure really what to do. Do you know of anything?
No, I'm thinking it's probably just bandwidth issues, but
It
please,
could be.
yeah. Everyone, I understand that her audio is breaking up a little bit, but I can hear her and I can clearly understand her. It is being recorded, so if you missed anything, you can check back with the recording. So go ahead, Kathy. Thank you.
Okay, sorry about that. Okay, so partitioning, let's take a look at that. I went ahead and created, again, did most of the work ahead of time to avoid sitting here for 10 minutes watching it run. And I'm going to work with copies of that that big transaction history table again. So what I did is I created two tables, one called transaction history and one called transaction history 2010. And I also created a couple of partitioning functions, or I'm sorry, one partitioning function. So let me just take a look at how the data looks in this table. And I'm going to use the row table because the performance is better. Still takes a bit. Okay, so we can see how the data is divided up over the years. There are two things you need to do, and I'm sure that I haven't really looked to see if there's any Pragmatic Works webinars about partitioning. There probably is. But the first thing you have to do is create a partition function. So you tell the function how you want the data divided up. So in this case, I'll have all the data that's less than 2008 in one partition, then the next one will have all the 2008 partition data, and then the 2009, and then 2010 and later.